Well, it's lost. Hey, welcome everybody. I'm Serhat lbetekin. I'm working in Netherlands as a lead DevOps engineer, and today I'm going to show you in a small presentation, and then I will do most of my work on command line and AWS console, so it's going to be quite technical. So I hope you enjoy it. I'm going to talk about the infrastructure. I'm going to build all the infrastructure on AWS using Terraform and Puppet. And this is going to be all the core infrastructure. And what we are going to build is a Kafka ecosystem where we will have our Kafka zookeepers. We will have our Kafka Brokers and some management tool where we can manage all that ecosystem. And we will have obviously our Kafka Connects where we can read data from one source and then write into another source. And I will explain some domain events and then how I improved or how we improved all this architecture with Cassandra and Spark. And well, at the end, it will be mostly a live demo. The infrastructure part, as I mentioned, it's AWS. We chose AWS as our cloud computing platform. Because it gives us a lot of flexibility to scale our applications. We chose Terraform, which is a HashiCorp tool, which helps us to design and deploy our infrastructure as a code, which is it's a great tool where you can just bring up a really big infrastructure with just one button. We have a Jenkins server where we deploy our Kafka Connect connectors using code deploy at the end using the Amazon code deploy. And we have Puppet, obviously, where we configure all our servers, all our Kafka zookeepers, brokers, all management tools using Puppet. The first part of the infrastructure is already built because to build a Puppet master on Amazon, it takes around 20 minutes, and I don't have those 20 minutes here. So I want to prefer using that time explaining how Kafka works internally and how we build Kafka clusters in AWS. So I have already working Puppet master on AWS and an OpenVPN, so I can connect all to my servers via internal IPs. The first thing I will explain are the zookeepers, but before that, I want to go back to my console. So I'm going to bring I don't know if you can see it. I'm going to make some zoom. So I'm going to bring up now all my Kafka zookeepers, all the brokers, management tools, and connectors. Basically, I'm doing a make apply, which is a abstraction of Terraform. What it's going to do, it's going to bring, or it's going to download all the modules. It's going to apply all the configuration files I have on my machine. And as you can see, it has already some configured stuff like my AWS VPC. It has all the subnets configured, the Puppet master server with the load balancers, all the EC2 security groups and everything. And then it will start bringing up, I think, around 200 new resources in less than 4 minutes. So it's, yeah, you can see that it's going to add 194 resources onto Amazon. And we can see it here, for example, that it's going to add some SQS queues. It's going to add some security groups for the zookeepers. It's going to add, for example, some Kafka Connects for my SQS, for S3. So it's going to configure a bunch of stuff. And we can see it in Amazon console. So if you go to here, we can see that I have only, I have an OpenVPN server and a Puppet master running. And now in a couple of minutes, we will have 3 zookeepers running, and then the rest of the security groups will be to 0. Then I will start bringing up all my cluster. So if you go back to the console, we can see that it already started creating all the auto-scalings, all the launch configurations, all the necessary configurations on Amazon Web Services with just one button. And we can go to our Amazon console. So I had only one auto-scaling group, but now in some minutes, So right now it's maybe configuring some security groups. So here you can see that all the security groups for Kafka are already configured. And if you go back to our auto-scalings, as you can see that I have now lots of auto-scaling groups, and right now I had only one Puppet Master server, and this will bring up Zookeepers, Kafka Connect for S3 cluster, Kafka Connect for SQS cluster, our brokers, and the Kafka manager. So I want to go back to my slides and explain some about Zookeepers. Okay, yes. Kafka Zookeepers. We configured those Kafka Zookeepers using one module from the Forge, Puppet Forge. You can have the link here. We are going to create, I'm going to create 3 small Zookeepers because it's going to be a really small deployment. But for larger deployments, for Quorum, you can have 5 or 7 Zookeepers. It's going to depend on your cluster. Zookeepers are used for the brokers, so to manage and coordinate the Kafka brokers. They basically brokers depend on the Zookeepers for a couple of reasons. One of them are if there's a server failure on one of the brokers, then another broker will spin up using the auto-scaling from Amazon, and then Zookeepers will synchronize, add this new Kafka broker into the cluster. And also for the data partitioning, we will have our brokers, we will have our topics, and we will have some partitions, so Zookeepers take care of those data partitioning. And always the data replication, so you will never have your data in just one server, you will have in a couple of servers. Kafka is moving out most of their configuration from Zookeepers into Kafka, so they don't want to rely on a lot on the Zookeepers. So since the version 0.8.2, they moved their offset storage from Zookeepers into Kafka. Well, this is still configurable. You can configure in Kafka where you want to save it. You can save on both, but you have to configure this. So let's bring up 3 Zookeepers. So everything is applied, as you can see. Now I have a cluster. So I have everything to 0. So I'm going to bring up 3 Zookeepers. I can do this part with Terraform, but it takes around 2 minutes. So I just want to save some time and show something cooler. So now it's going to bring up 3 Zookeepers. And we will see how it is configured using Puppet. If I go back to here, I'm going to explain you meanwhile the brokers. The Kafka brokers are where all the data is stored. So you can read from one data source, and then you save it onto Kafka, and those are stored in brokers. So today we will have 2 brokers, 2 servers, and then we will have 2 different topics. I'm going to fire up some domain events from some microservices, and those microservices, for example, you are on an online web page, and then you visit a product, which triggers a domain event, which will be the item visited, because you just visited a product. And then if you purchase this product, then it will trigger another domain event, which is going to be the item sold. So those domain events are stored in one broker, and they are all inside the topics. So the topics have different partitioning. So you can have 10 partitioning, or you can have 100 partitioning. It depends on your application and how you are going to read, produce, and read those data. So imagine we have our topic item visited, and we have 10 partitions. And in each server, you will always have one leader partition. For example, as you can see, the red ones are leader, and the blue ones are the followers. So if you look at the topic item visited, the partition 0 in the broker 0 is the leader, and on the other side, it's the follower. leaders are taking care of all read-write of your data into the topic. And you can repartition easily using some management tools that I will show you in a couple of slides. And let's see if our Kafka zookeepers are alive. So then we can bring up our Kafka Brokers. So let's see our instances. Yes, we have 3 Kafka zookeepers. Now they are in sync. And what we will do is we will just bring up some Kafka Brokers. We can bring up, depending on your need, you can bring up 2, 3, or as many as you want Kafka Brokers. So today we will add 2 Kafka Brokers. And then we will just wait that they are configured. So these are some screenshots from the Kafka Manager tool, which is from Yahoo. You can use it. It's open source. And basically what it does is it just shows you some management of your topics, your brokers, and all this partitioning. You can repartition all your data. Instead of using the command line, which can get really complicated, you can make lots of mistakes, but then you have this web page where you can install, and then it connects with your brokers and zookeepers, and then you can just say, okay, I don't want 10 partitions because our applications have more data and we have to read it faster. Then you can have, instead of 10, you can have 100 partitions with just 2 clicks, or you can add a new broker which will just synchronize. You can have, you can select the leader. Okay, say, okay, I'm gonna shut down one of those servers because Amazon marked it as that it has a hardware issue. Then you can select that as a follower, and then you set the other broker as leader, and then you can shut down one of them, and then you can bring up a new Kafka broker. So you can have this management tool installed, and it gives you a lot of flexibility while you are configuring. So let's go and see if we have our, let's make some zoom. I'm going to get my Kafka IPs. So these are my Kafka servers. I'm going to just okay, it's not going to work because I'm not connected to my VPN. So I'm going to connect to my VPN. Yes, it's live. So let's try again. Yes, I'm in. As we can see that everything was configured using Puppet, or it's still creating some configurations. So Puppet comes and then it starts creating all the configuration that we need using the Puppet Forge module. Once it's finished, we have to configure some internal configurations for Kafka, like where we are going to store our offsets, where we are going to store the Kafka Connect offsets, and the storage and the configuration files of our Kafka Connects. So it looks like everything is okay, everything is running. So what I need is, I just need to create some, zoom. Using the zookeepers, I'm going to create the connect config SQS, which is going to be where I save my configuration files for Kafka Connect. I'm going to have Kafka Connect SQS for offsets, where I'm going to save the offsets for my Kafka Connect and the status of my. So let's take one of the DevOps Kafka zookeeper. So I'm going to run some command lines to see. So this is a follower zookeeper. So we have one leader zookeeper and we have two follower zookeepers. You can select the leader to run your configurations, but it doesn't matter. You can run also in the followers, and which will be replicated to the rest. And here we can see that this is a command to check, to list all your broker IDs from Kafka. And then here we can see that we have two Kafka brokers already registered in that particular zookeeper. So it gives some random IDs to your Kafka brokers, which is 288 and 175, but it can change anytime. So let's run all our configurations. Just gonna just paste it. So you have to do this just only once, because when you bring up a new Kafka cluster, the brokers are empty. So you have to configure those configuration files once, and then if your broker, one of them goes down, it will bring up a new one, and then it will be synchronized, so you don't have to do this multiple times. Just doing it one, it will be enough. So let's bring up the rest of the architecture, which are going to be one Kafka Connect for S3. So let's see. I'm going to bring one Kafka manager. And the last one is going to be for the SQS. So I'm going to talk about Kafka management tools. So we are using 4 different management tools. The first one is the Kafka Connect UI. This is where we set up all our Kafka Connect cluster, but we need to see where we configure it. So you create some connectors, you have to manage them, and it makes it really easy if you have a web UI. So Landup, which is a company that creates different web UIs for Kafka, and we just take their code, which is open source, you can use it, and then I will show you how it looks like. Kafka Manager, it's from Yahoo. It's just to manage Kafka topics, consumers, offsets, brokers. You can bring up new brokers and add them to the cluster. And also, we have Kafka REST, which is the RESTful interface for the Kafka cluster. So you don't have to do all the configurations using command line. And the topics, we will see how many topics we will have. In our case, we will have 2 topics, which is the item visited and item solved. And this is, again, from Landup. And Kafka REST is from Confluent. I don't know if you guys know it. Confluent is the company where the creators of Kafka, they left LinkedIn, and then they created that company, and they are giving some, creating really great open source codes. What's Kafka Connect? Kafka Connect is to scale, create, scale, distribute your data streams from one source into another using Kafka Brokers. You can have lots of data going around in your infrastructure, but you have to put them somewhere centralized. So you use Kafka Connect to take data from one source and put it into another source. So there are 2 types of connectors. One of them is the source connector, where you import data from one system. It can be SQS, it can be Kinesis, it can be some other like MongoDB or wherever you want. And then the sync connectors are where you export the data. So you ingest your data using the source connectors into Kafka, and then you read your data using sync connectors from Kafka, and then you export it somewhere else. It can be S3, it can be HDFS, or it can be a Cassandra server, or wherever you want. You can have lots of multiple connectors in Confluent page, which are open source. We are mostly using those Kafka connects. So here you have the Confluent connectors. For example, You can have the Amazon Sync server where it's an exporting data from Kafka into S3. The same for Elasticsearch, or you can have databases. And also there are like some open source ones, like additional connectors that from the community. And there are lots of like from DynamoDB, CoachDB, and like whatever you want. You can find it here, Redis, Splunk, Solar. So you can configure, just download their code, and then just run it in your Kafka Connect servers. So let's check if our Kafka Connect is ready. Yes, it's ready. And let's go to the S3 one, and let's go to the Kafka Manager. Yes, so everything's ready. So here I just brought up a cluster of Kafka Connect, and this is going to be just dedicated for my SQS. What I will do with Kafka Connector is I will read data from one SQS and then write into the Kafka. And I have another one, which is the SQS Kafka Connect cluster, sorry, S3 Kafka Connect cluster. And it is going to read data from Kafka and then export it to S3. So let's add a cluster. Cluster name is DevOps Barcelona. And I need the zookeeper list, which I can get from here, from using a Puppet factor. I'm going to get list of the IPs and ports of my zookeepers here. Oops. Now I'm going to enable just some extra configuration that I need and save. So now we have configured a Kafka cluster where it says that we have 7 topics. The ones that I created previously, they are the configuration topics for my Kafka Connect. So this is going to be for S3, this is going to be for SQS, and I'm going to check how many brokers I have. As you can see, I have 2 brokers, and you can go and just check what are they doing and what partitions they have. For example, the consumer offset has 100 partition with a replication factor of 2, and you can see all the partitions. And if you go into one of them, one of the topics, you can see which one is the leader, which partition is the leader. For example, this partition 0 is the leader on Kafka Broker 175, and the replica or the in-sync replica is 288, and then just continues. So I'm going to run this script where it will create my Kafka Connects. First one is ready, and the second one is ready too. So we have 0 connectors. If I just do a refresh, I will have 1 connector here and another one here. So what it does, the S3 one is going to read. So I'm using this connector class. I'm using this S3, so I'm going to save all my data in this S3 bucket. And I will flush each file whenever I have 10 domain events. I will be saving into I will be reading different topics from my Kafka, which is going to be the item sold and item visited, and some different, and the path format in S3, it's going to be the year, month, day, and hour. And in SQS, it's exactly the same, but then I'm reading from a source queue, which is DevOps Barcelona-Kafka, which is my SQS. So if I just refresh here, I just created one SQS queue where I will be sending all my data. Right now, it has 0, and now I will just ingest some data. So we will start seeing some data soon. So let's continue. So domain events. Our domain events look like this. So we have lots of mobile applications. We can have a web page. We can have an e-commerce store. Whatever event the clients do, we want to capture all of them. In our case, we are going to have this domain event where we'll have some attributes, some type of the event, ID of the event, user ID, item ID, where we need all those info to be processed later because our analytics department want to do some analytics on those events. So basically, we are sending all those domain events into an SNS, which will end up in an SQS queue. The problem here is SNS, when they deliver, it is at least once delivery. It means that you can have duplicated events. So we will see how we can solve this. So I'm using this Kafka Connect for SQS. You can download it and you can use it. For S3, I'm using this sync connector, which is from Kubernetes Trimix. Basically, I will have one source connect, which will read data from this SQS right into Kafka, and then it will just export it to S3. So let's see if this is really happening. So yes. So as you see, we have message in flight, means that Kafka SQS connector is reading data from this SQS key and writing into our Kafka brokers. So let's go back to our topics. We had 7 topics. Now we have 9 topics. As you can see, we have items sold and item visited, and we have 225 events already stored in item visited topic and 221 in item sold. So if you click one of them, you will see exactly how, like, it has 10 partitions, how many offsets or how many messages are in one of them, which broker is the leader. And if now we go back to our empty bucket we had previously, now we will have one folder called topics. Let's see why it's not. Should be reading and writing. Here. Okay. So right now it's writing into Kafka using the SQS connector, but it's not reading data using, maybe I have some permissions issue. So let's see, roles. Kafka Connect S3. I have S3 full access. I'm not sure why it's not working. This is what happens when you are brave enough to create a Kafka connector live. So let's connect and see why it's not writing. So if I go to my logs, it says that it's writing. So let's go back. Yes, it's writing. So it's just some delay. So we have item sold topic stored already in S3. We go to our folder structure 2018-04-10, hour 13. Well, it's 2 hours earlier. So we have all our data stored in S3. So what we can do is we can just check it. Amazon has this new functionality that you can read from. You can read the data from S3 directly. Just select from. It's a JSON document, and you can just say, hey, give me all the domain events, let's say 10. And you will have all the data stored here. So this is our, this is the file that is stored in Amazon. So let's continue now. So what happens is that if you have a platform that you really rely on SNS and SQS, but SNS is just delivering duplicate messages, you have to deduplicate before saving in S3, because otherwise your analytics department will come and say, hey, we see that in our database there are 10 sales, but Kafka says we have 15 sales. So what happened? So in LetGo, so I also worked in LetGo as a consultant. In LetGo, the developer developed a Cassandra sync connector. What it does is just deduplicates all those events, and they have a Hadoop cluster where they have a Spark job that comes and picks that data that is in Cassandra, and then they write it into S3, but not using JSON format, but they are using Parquet because they want to, later on they put it in HDFS, or they can put it in Redshift, they can import it, and for faster processing. So what we did is we ingested some data into SNS, which ends up in SQS, but some of them are duplicated. We consumed the data using Kafka Connect SQS connector, and then we used sync connectors, which is the Kafka Connect S3 connector, sending all this data, reading from Kafka Brokers into S3. You can use different partitioning. You can have like time partitioning, or you can have like different other partitioning. If you read the source connector, you can have all that information. And we saw the results in Kafka Manager. My script still is just ingesting some data, and we can see it here that it's just growing. And if you go back to your Kafka topic, we had 200 messages. Now we will have like more messages. We have like 700. It just keeps increasing. In LetGo, we don't have like 700 messages, or we don't have 1,000 messages. We have billions of messages per week going through our Kafka clusters, which is in production. And I think we saved more than a couple of trillions of domain events in S3 using this platform. And the platform is really simple. It has just 3 zookeepers, 3 Kafka Brokers, 1 Kafka Manager, and 2 Kafka Connects. With like 6, 7, 8 servers, you can save like trillions of domain events into S3, and then your analytics department can come and say, okay, let's process all these events using Hadoop, or they can import it into S3, in Redshift, or any other analytics tool. What we can do is, we have some time before the questions. I want to add a new Kafka Connect and see how it's being clustered. So okay, thank you. So let's say we bring up a new SQS. Instead of 1, let's bring up a second one. And let's go to our Kafka Connect. So here you can see that there are 2 tasks running on this Kafka Connect. And they are running on the same machine, because I have only 1 Kafka Connect server. So now I'm bringing up a new one. So this will be balanced. So you can run your Kafka Connect in clusters as well. So also let's bring up a new broker. So instead of 2 brokers, let's make 3 brokers. And then I will show you how you can balance this in using Kafka Manager. Here in Kafka Manager, we have only 2 brokers. When a new broker comes up, it will be added automatically to the cluster, and then you can repartition all your data. Instead of in 2 servers, you can have it in 3 servers. You can also have, here you can see reassigned partitions. You can have preferred replica actions. You can have different topics, so you can create topics using Kafka Manager. You don't have to create them using like command line scripts. You have some consumers that you can see. For example, for our S3 items, there is a 16 messages lag, which is just, it's going a bit slower because I have small machines. But in your production, you can use this Kafka Manager tool to see if you have any delays on your messages being delivered from Kafka to S3. While it's coming up, if you guys have any questions, my presentation is done. So if you have any questions while it's coming up, I appreciate it. Let's see. Yes, as you can see, I have a Kafka Connect for SQS. It is one of the tasks are running in 111, and the other is running on the new server, which is the server ending up in 22. And if we check our Kafka manager, in like a couple of minutes, we will have the third Kafka broker coming up, and it will be in the Kafka cluster. Yes?
It doesn't work? Yes.
Yeah, yes.
I would like to know the infrastructure in AWS is made of what type of server? What is the scalability you expect in terms of messages per second?
Yeah, so what as you know, all the Kafka products are written in Java. So what we try to use are the M-style servers on Amazon, which are the memory-based servers. And in this demo, I use some M-large servers, as you can see, for most of the servers. And in Let Go, I think we use M4 2x large servers. But, well, now we are moving to M5 2x large servers. But with like 3 servers of M4 2x large, you can run like trillions of events, and you can save them into S3. Yeah, and even you can have it like smaller ones like M4 larges or X large, but they have to be like optimized memory-wise. You can't use like C4s because then it will have lots of problems. And for the Kafka Manager, Kafka Connect, you can have smaller ones because at the end of the day, it's just a web application. You can have even like T2, whatever, small, medium, or it depends how many people you have in your company accessing those management tools. And let's see if we have the third one. Yes, it's there. So we have the third Kafka broker joined to the cluster. So if you go to your topic list, there will be some issues here. So broker spread, what it means that you have 2 brokers, and the last broker that joined the cluster, it's empty. So you have to rebalance all your, so what you can do is you can generate partition assignments. You can select, for example, your item sold and item visited, and then you say, okay, then please, those 2 topics are partitioned on all those 3 brokers. So go back to list, and then run partition assignment, and select all these 2. Done. So if you go back to your list, so what will happen is that it will just take the topics from one, and then it will just move to the other one. It will replicate, depends on your replication factor, and this 66% will disappear, and it will be 100%. You see that now it's three brokers, and it's just 100%. So it just disappeared. Well, you can do the same for the rest of the topics, but we just care more the item sold and item visited. So now they are replicated in 3 different brokers. Any other questions? No? Thank you.
Yeah, hello.
Yeah, sorry.
Yeah. Serhat, over here. Right.
Yep.
Top. Yeah, thank you, right. Thank you for your great talk. Just a question out of curiosity. How much money will you pay for 1 trillion of events in that S3 bucket? I mean, is this something that a client ever paid, or?
I don't see the Amazon bill because I don't have access, so I can't, I can't tell you. Well, depends on, I think it was 500 gigs of data on S3 every day, so 1 year of events, you can just calculate. So I don't know how much it will be, but cool. It's quite a lot of money, but it means that if you have 500 gigs of data, it means that your company works great, right? So you don't mind the money you waste on that. Thank you. Any other questions? All right, thank you.